Next up, we want to look at the hybridization of iodine in IF3 and IF5. So let's start with IF3. Valence electrons, I have 7 by 3 plus 7, which is just 7 by 4, giving me 28 electrons. So I'd have my central iodine, as we did before. Fill in the octets of all the fluorines. And this would give me 6 by 3 plus 3 by 2, which is just 6 by 4, so 24 electrons. Clearly not my 28. The only place the other 4 electrons can go is on the iodine. And then now that my valence electrons are all taken care of, let's just double check on my formal charges. Fluorine is going to be 7 minus 6 minus 1, 0. Iodine is going to be 7 minus 3 minus 4, 0. So they're both have a formal charge of 0, and this is my best structure. Now I check the steric number. I have 3 attached groups plus 2 groups that are lone pairs. So my steric number is going to be 3 plus 2, which is 5. Its notation will be AX3E2. This is my number of bonding pairs, my number of lone pairs. And so now that I have that, I can go check its geometry. This VESPA chart does not list that, but another good way to remember it is that my total orbital should add up. And so I usually have 1s orbital available to me, 3 p, so right now I have 4, and then I'm going to need to add 1 from the d in order to get all of those exponents to add up to 5. So the central iodine will be sp3d1 hybridized. Now let's check out IF5. And this one has 7 by 6 electrons for its valence electrons, and that is going to give me 42. So I have I in the middle, and my terminal fluorines. Fill in everybody's octet. And so now I've covered 5 by 6 plus 5 by 2. This will give me 30 plus 10, which is 40. So I have 2 more electrons left over. The only place to put them is on the central iodine. And so that's going to be that. Double check your formal charges. For the fluorines, I have 7 minus 6 minus 1 as usual, so 0. On the iodine, I will have 7 minus 5 minus 2, so 0. And so this is definitely our best Lewis structure. And so now I will check the steric number, and it will be 5 plus the 1 lone pair that I have, so 6. Its notation will be AX5E. So the 1 lone pair and the 5 bonding pairs. So its electron geometry is going to be octahedral. Its molecular geometry is going to be square pyramid. And its hybridization, as mentioned before, I only have 1 s orbital. I have 3 p, so far I have 4. I need a total of 6, so I'm going to add 2 from the d. And that's going to be it. So its hybridization will be sp3d2. And that's going to be it for this question. So the first answer is sp3d1, second answer is sp3d2.